Alright, this video covers notes 13.4. If you are watching this video to get ahead, this is an activity that we are going to do in class, so do not watch this video. However, if you were absent on 13.4, this is an explanation, or if you are here on 13.4 and just need another explanation, here are the problems once again. So, the bell work has asked us, is the table to the right an example of direct variation? If so, write the equation below. Just like we did on 13.3, we're going to take this table and put it into stat edit. So I have 2, 4, 6, 2, 4, and 6. So I make the table in my calculator look exactly like the table on my paper. I click stat calc 4, enter, 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 and my equation is 1x plus 0. So we don't have to write the plus 0. So my equation for this table is y equals 1x. Now, like we talked about on 13.3, direct variation means it has no number after the x that follows. This one does not, so yes, it is an example. My equation is y equals 1x, or just y equals x. Now, the activity that we did in class for 13.4 says the following problems have been factored for you. You need to use the boxes on the right to work the problem out yourself to determine if you want to prosecute or defend the answers shown. So what they've done is they've worked it, we're asked to work it, and then decide if we agree. So problem 1, and this is written on your paper, you have 3p squared minus 2p minus 5. So when I look at this, the first thing I ask myself is there a GCF? Nope. So I can go ahead and put it in a box. I have 3p squared minus 5. Let's scoot it down just a little. So 3p squared minus 5. My product is negative 15p squared. My sum is negative 2. So I take my product and put it in y equals. And I look at the table for two numbers, an x and a y, that will add to a negative 2. 3 minus 5 would give me negative 2. So I put 3 and minus 5. Both of these have p's. I take out what they share. So 3p squared minus 5p. They do not share any numbers, but they do share a p. 3p minus 5. Again, they do not share any numbers, but they do share a 1 as a placeholder. 3p squared and 3p share a 3 as well as a p. Negative 5p and negative 5 share a negative 5. So my answer is p plus 1 and 3p minus 5. Now, does this match? Oh, it does not. They have 3p plus 5 and p minus 1. So my factors, negative 5 and 3, they use negative 3 and 5. So, prosecute, disagree, defend, disagree. I would choose to prosecute this person, and yours ask for a reason why. The reason why would be your factors don't add to a negative 2, specifically that negative part. 5 minus 3 would get you 2, but we need a negative 2, so my factors would not work there. Problem 2, we have 2y squared plus 11y plus 5. So I'll use my box, and I'm trying not to peek at their work because I want to see what I get and then compare. So 2y squared plus 5. My product is 10y squared. My sum is 11y. So I'm looking for two numbers that would multiply to 10 and add to 11. 10 plus 1 would get me 11. So 10 and 1. From here I take out my GCS, so 2y squared and 10y share 2 as well as a y. 1y and 5 do not share anything. 2y squared and y share a y. 10y and 5 share a 5. So my factors are 2y plus 1 and y plus 5. So this is the same, but this one is different. I got a 2y plus 1, and they just got y. Let me see what's different in my box. I used the same factors, but flipped. Oh, look what they did here. They did not put the first thing in correctly. So I would prosecute this one as well, because they did not put factors or terms, I'll say terms, in the box correctly. Okay, I have a 2y squared because that's what my problem has, but they only have a y squared, so they did not do it correctly. Okay, problem 3, I have 10b squared plus 38b plus 24. So when I look at this one, these are all even, so I'm going to take out a number. I can take out a 2. If I can take out a 2, I'm going to check for 4. 4 does not go into 10 or 38 nicely, so I can't take out a 4. I cannot take out a 3, so I can't take out a 6, so it looks like the only thing I can take out is a 2. But I'm going to go ahead and take that out, so we have a 2, and then 5b squared plus 19b plus 12. In my box, I have 5b squared plus 12. So my product is 60b squared. My sum is 19b. So in y equals, I put 60 divided by x, and I'm looking for two numbers that would add to 19. 15 plus 4 would add to 19. So 15 and 4, both of these are positive. So I take out my like terms, 5b squared and 4b only share a b, 15b and 12 share a 3. 5b squared and 15b share a 5b, and 4b plus 12 share a 4. So my factors are b plus 3 and 5b plus 4. Oh, yeah, and the 2 in front for my GCF. And they have 2, 5b plus 4, b plus 3, so I would defend because this person is not guilty because I agree with their work. So problem 4, 9c squared plus 66c plus 21. So the first thing I notice is these are all divisible by 3. 9 cannot come out of 6, and 6 can't come out of 9, and 9 can't come out of 21, so it's only going to be a 3. So I'm going to take out a 3 here and have 3c squared plus 22c plus 7. So 3c squared and 7 go in my box. I multiply them for my full product of 21c squared. My sum is 22c, so I put 21 into y equals and look at the table. I'm looking for two numbers that will add to 22. 21 plus 1 would give me 22. So I have 21 and 1c. Take out my GCFs, 3c squared and 1c only share a c. 21c plus 7 share a 7. 3c squared plus 21c share a 3c. And 1c and 7 do not share anything. So my answer is the 3 that I took out, c plus 7, and 3c plus 1. So let's compare. Whoa, they have 9c plus 3 and 3c plus 21. Holy cow. What do we do differently? Oh, they did not take out a GCF. They did not take out that 3 before they went to the box. So let's look. If this is something you forget to do, and we're going to prosecute, forgot the GCF. Okay. Now on the test, if this is something you forget to do, watch what you can do to kind of save your butt. If you're looking and you're like, oh crap, there's a GCF and I just did all the work, you could take your GCF out of every factor. So 9 divided by 3 is 3c. 3 divided by 3 is 1. 3 divided by 3 is C. 21C divided by 3 is 7. And now look. Now my factors match. So if you get to the end and you realize that there's a GCF, you can take that GCF out of all of them. However, I don't recommend waiting until the end, because some of these answers on your test on test 13 are going to have the GCF intentionally left back in there. So this might be one of the answers, and even though it looks like what we could get, it's not correct because you haven't factored it fully.